I need you to be attentive. We are first going to start with single replacement reaction. All right. The first reaction that I'm going to do in single replacement is an aluminum strip is immersed in an aqueous solution of silver nitrate. Do you see that? All right. As it says, it's a single replacement reaction. So aluminum is put into silver nitrate. All right? So when we predict products, we should always remember the periodic table. All right? In a periodic table, the metals and ammonium are all positive. They all like to lose their electrons. All right? The non-metals and all other polyatomic ions are negative. Okay? Now, so if I were to write this reaction, I'm going to try and say this is blue. All right? I like to use blue or black in this case for metals, plus that is silver, and my nitrate is my non-metal. Can somebody predict the product for me in this case? Now, I'm going to teach you these things in a certain way. It's not to offend any student, or sometimes it can even be disgusting if you hear it. All right? But somehow when I teach it, it sticks in my students' memory. So please pay attention as I teach, all right? They remember better, all right? I like to call my metals my males and my non-metals my females, all right? Remember, a metal and a non-metal will always combine, all right? So, can somebody tell me what the products are for this reaction? It's a single replacement reaction. Remember, a metal can only replace a metal, and a non-metal can only replace a non-metals. You can't put two metals together, or two males together, or two females together, or two non-metals together, because one loses electron, one gains electron. It's not possible for two elements that both lose electrons to come together. Does that make sense? There is no bond formation in such a case. What is the product of this reaction? Okay, so silver steps out, plus the other product is aluminum nitrate, all right? Aluminum, and then aluminum has a charge of 3, so aluminum nitrate formula will be AlNO3. Is that right? Now, it is not enough if you just look at the elements and say, okay, the metal will replace the metal, the non-metal will replace the non-metal, and these are the products. In order to make sure a reaction happens or not, you have to look at the metal activity series. This is the metal activity series. All right? Let's go down. This is the metal activity series. All right? So, again, listen to me very, very carefully. This is, the bottom half is the metal activity series, all right? And this is used for single replacement reaction. What is it used for? Single replacement reactions. Are we good? This table is used for single replacement reactions only. All right? Single replacement reactions only. And let's understand how to use this table. All right? In order to understand this, I go back to my discussing example. All right? And here is my example. All right? So, in this example, there is one female and there are two males. So the female gets to choose. All right? The female is currently going out or is hooked up with silver. Now, in order for the female or the nitrate to dump silver and go with aluminum, aluminum has to be more active, all right? Otherwise, she doesn't prefer aluminum's company. She's not going to break up with silver. Does that make sense? All right? Or in other words, if I go back to the metal activity series, all right, the metals are arranged from the most active metals to the least active metal. Does that make sense? So right now, we are comparing silver and aluminum. So aluminum is more active than silver because it's higher up in the periodic table. Is that right? So when nitrate is looking at aluminum, she's going to dump silver because this metal is more active. This reaction will happen. It will occur. Does that make sense? So if I put an aluminum rod inside silver metal, sparkles. How do they make sparkles? Silver will get deposited on the aluminum metal rod. It will look very beautiful. All right? We can do this experiment. Now, this is a solid. This is aqueous. It says it's a solution of. That's a solid. That is aqueous. The reaction is not balanced. So I'm going to put a 3 and a 3. Is that understood? Let's do another example. All right? Okay. All right, we're going to do another example of single replacement. Okay? And this time, we are going to choose a piece of zinc is dropped into water. That's the reaction we are going to try and see, and we're going to predict the products. All right? So my reaction is zinc plus, well, zinc is male, so I'm going to make that black. All right, zinc plus, how am I going to write water? HOH. So again, the female, which is the hydroxide ion, gets to choose between hydrogen and zinc. So zinc has to be higher up in the periodic table for hydroxide to dump hydrogen. Is that right? Shouldn't zinc be more active? Yes or no? Do you agree? Otherwise, she's not going to dump hydrogen. Now, let's go to the metal activity series. All right? So, here is zinc. Here is zinc. And here is hydrogen. Are you with me? So, you will say zinc is more active than hydrogen. So, hydroxide should definitely dump hydrogen and go with zinc. But, I need you to pay attention to the detail that is given on the side. It says metals from lithium to sodium will react with acids and water, whereas metals from magnesium to lead will only react with acid, will not react with water. All right, no reaction with water. No reaction with water. So if I take zinc pellets and drop it into water, do you expect to see a reaction? No, there is going to be no reaction. So in this case, you will conclude that there is no reaction. Are we good? Do we understand this? Okay? We're going to take one more example, and you're going to do this example. You're going to do fluorine gas is bubbled through a solution of calcium chloride. Okay? So fluorine is my female plus calcium chloride. Okay. In this example, the male gets to choose because there are two females. There are 2 non-metals, so calcium gets to choose. So if you go back to the metal activity series, all right, if you go back to the metal activity series, it's mostly metals. We're only going to learn one for the females or the non-metals. The only one we need to pay attention to is the halogens. So who is the most active female? Fluorine. Everybody in town wants to go out with fluorine. All right? Fluorine is more active than chlorine, than bromine, than iodine. Guys, I think there is a total of just 3 labs in the entire world where chemists work with fluorine. Fluorine is so highly reactive as an element that it will go through your bones if it escapes. All right? So the measure of safety that you should have when you work with fluorine is really immense. So in the world, there are just 3 labs that will allow you to work with fluorine gas. All right? And most of the fluorine is formed as fluorides. Okay? So every metal wants to go out with fluorine. There is no free fluorine, so to say. All right? Now, let us go back to our predicting products here. So calcium was going out with chloride. Do you think calcium will dump chloride and go with fluorine?
Yes.
Of course. All right? So the compounds are going to be calcium fluoride plus what comes out? It's now an element. So it will come out as fluorine gas. And how do you write? Fluorine F2. It's a diatomic element. Calcium is a +2, chlorine is a -1. So the formula is CaCl2 giving CaF2 plus chlorine. The reaction will happen. All right? Instead of fluorine, if it had been bromine here, do you think calcium will dump chlorine? Instead of fluorine, if it had been bromine, do you think the reaction will happen? No, the reaction is not going to happen. Does that make sense? Okay? We said fluorine was the most active female. Like with other non-metals, we are not going to ask you to compare. Only for metals, we'll give you more examples with metals. I said instead, in this reaction, instead of fluorine, if it were bromine, will the reaction happen? Will calcium dump chlorine for bromine? No, that's what I was trying to get to. Yes?
How do you represent an acid?
How do you represent an acid? Okay, which question is that? Let's go to that.
No, because you know how you said some things like acids.
Acids begin with a hydrogen. All elements that begin with hydrogen except water are acids. Okay? Now, let's go to double replacement reaction now. Okay? We are going to see the product of a double replacement reaction. Now, we're going to do the very first example. All right? With sodium phosphate and manganese 2 chloride. So this is a double replacement. What was it? Sodium chloride, right? Is that right? Sodium chloride and manganese 2 phosphate. Is that, no, what is it? Manganese 2 chloride and sodium phosphate. Is that right? Is that right? Did I write that correctly? It's sodium phosphate and manganese 2 chloride. Correct. Okay. Guys, can somebody predict the products of this reaction? So remember, in chemistry, you cannot put 2 males together or 2 females together. All right? Again, it's a concept of losing and gaining, which leads to bond formation. Is that right? Does anybody want to predict the product of this reaction? What will be the product? Justin? No, how this is the male, this is the female, right? This is the male, that is the female. So what happens in a double replacement reaction? They switch. Is that right? So what are the products of this reaction? Uh, no, don't give me the formula, just give me the name. Sodium chloride plus manganese 2 phosphate. Okay, so in order to predict which double replacement reactions will take place, here is how you can predict. The reactions that make a solid, a liquid, or a gas will occur or will happen. Other reactions, other double replacement reactions will not happen. Okay? So how do you know if you're making, so did you write this down? Make a solid, a liquid, or a gas will happen. Are we good? Do we understand that?
Yeah.
Okay. What does that mean? So we're going to learn about that. All right? So let's look at this chart. So we're going to go to the top of this chart. By the way, this chart will be provided to you when you take your test or quiz. Okay? All this information will be given to you. You should just know how to use it. So this whole chart is used to determine, it's used in double replacement reactions, and it's used to determine the formation of a solid. Yeah, you'll get the same sheet. Yeah. Okay? So, now, soluble means not a solid. Alright? Insoluble means it is a solid. Insoluble, this is going to be a solid. Soluble means it's not a solid. Are we good? So we should know how to read this chart. Okay? How are we going to read this chart? So Justin, right? Kevin, no, Kevin is in third period, right? So we first look at the female portion. Where do we start first? We start at the female portion. It says chloride. So I'm going to go to my solubility chart and I'm going to look for chloride. Where is my chloride? Well, once I locate the nonmetal, I should then go to the metal portion of it. Alright? It's not enough if I just do one part. I should do the second part too. So where is my reaction? What is my metal portion? My metal portion is sodium. So I go to this chart again. Is sodium here anywhere for it to be a solid? If it is silver, it becomes a solid. If it's lead, it becomes a solid. If it's mercury, it becomes a solid. But it's sodium. So it's going to be a solid or not a solid? Not a solid. So it's going to be aqueous. So this reaction, this is aqueous. Are we good? Now we look at the second product. Where do we start? Where do we start, guys? We start with the female. We look at the phosphate. So we go down and we locate phosphate. Where is phosphate? Right here. And then I go across. What was my metal? It was manganese. Is manganese in group 1? Is manganese the same as ammonium? So what is manganese phosphate going to be? A
solid.
Is it group 1? Is manganese group 1? is it ammonium? So where does the compound fall? Here, right? If it had been group 1, meaning if it had been lithium, sodium, potassium, if it had been lithium phosphate, sodium phosphate, what would you say it will be? Not a solid, right? But this is manganese. So it's not group 1, it's not ammonium, so manganese 2 phosphate is a solid. Will this reaction happen? Yes or no? Did it result in the formation of a solid? Will this reaction happen? Yes, the reaction will occur. Yes, Hilly.
Oh, it says, wait, what would be an example of something that would be?
So you're going to stop the class here right now because